So today we are looking at Chapter 3, Lesson 3, Multiplying Decimals by Whole Numbers. This lesson begins on page 193. We are working with Content Standards 6th grade in the number system, 3rd standard, which is to fluently add, subtract, multiply, and divide multi-digit decimals using the standard algorithm. And so today we're specifically looking at multiplication, and we're specifically looking at multi-digit decimals. So we are actually going to go right over to page 194 and start on the examples on that page. So when we multiply decimals, using repeated addition can help you to place the decimal point. So if you're estimating this is about 0.83 would be about 1. If you had 1 4 times, your answer would be approximately 4. So keeping that in mind, it's going to help you to know where to put your decimals so that when you get your answer using the standard algorithm, you'll know if you have your decimal in the appropriate place. So my answer should be around 4. So if my answer is around 40 or 400 or 4,000, I know that I have my decimal in the wrong place and I need to move it so that it would be around 4. So for instance, 3.32 would be pretty close to 4. So using repeated addition can help you to place the decimal point. The whole number represents the number of times the decimal is used as an addend, so how many times it's added. So place the decimal point in the product the same number of places from the right as the decimal factor. So in other words, the same number of decimal places that are in the problem will also be in the answer. All right, so let's go ahead and take a look at example 1. We're going to use the workspace over here. Number 1. And I like to write the longer number. It doesn't matter if it's bigger or smaller. I like to write the longer number in the top row so that I have fewer times that I need to multiply. So I'm going to say 0.83 times 4. 4 times 3 is 12. Write the 2, carry the 1. 4 times 8 is 32, plus 1 is 33. 4 times 0 is 0. And you can write that 0 or you cannot write that 0. It's up to you. And whichever way you learn that in 5th grade is fine. Then I look at my problem. In my problem, I had 1, 2 decimal places. So in my answer, I need 1, 2 decimal places. So this will be 3.32. Okay, so that's my answer to number 1, 3.32. And then I check for reasonableness. 0.83 is pretty close to 1. 1 times 4 would be 4, so 3.32 is a reasonable answer. Let's do number 2. We have 14.2 3 times, so 3 times 14.2. Again, I like to write the longer number in the top row, and that way I only have to multiply by the smaller number. So I only have to multiply one problem. So I'll write 14.2 times 3. So you could do it the other way around, but then you'd have multiple rows here to add together. Okay, it would still work. It would just be more steps. So 3 times 2 is 6. 3 times 4 is 12. So we write the 2 underneath the 4, and then we carry the 1. 3 times 1 is 3, plus 1 is 4. And then I want to look at my decimal places. I have 1 decimal place in the answer, or in the problem, so I need 1 decimal place in my answer. So starting from the right, I move it over 1 place, and my decimal goes right there. So my answer is 42.6. Number 1 was 3.32. Okay, example 3 asks us to find 0.95 times 4. So example 3, 0.95, that has 3 digits, 1, 2, 3. 4 just has 1 digit, so I'm going to write that one next. Okay, 4 times 5 is 20, write the 0, carry the 2. 4 times 9 is 36, plus the 2 we carried is 38. You can do the 4 times 0 or not. We didn't. Okay, and then we have 1, 2 decimals in our problem, so we need 1, 2 decimals in our answer. So we get 3.8, and then we check for reasonableness. 0.95 is very close to 1. 1 times 4 would be 4. This is very close to 4. Okay, you can also think of it like money. It would be 95 cents. 4 times would be $3.80. Okay, next for Got It A, we have 5 times 0.25. So I'm going to do my work right up here, and I'm going to write the longer number in the top row. So 0.25 times 5. 5 times 5 is 25. We write the 5, carry the 2. 5 times 2 is 10. Plus the 2 that we carried is 12. Write the 2. You can either carry the 1 or not, whichever way you prefer. I'm just going to follow the algorithm all the way through. 5 times 0 is 0, plus the 1 that we carried is 1. Okay? So some of you might do it this way. You might say 5 times 2 is 10, plus the 2 we carried is 12, 1, 2, and write the 12 there. That's fine. And if your 5th grade teacher taught you that way, that's a great way to do it as well. All right, then we have 1, 2 decimals in our problem. So we need 1, 2 decimals in our answer, and our decimal will go right there. And it's 1.25. I started reading it again from the beginning. Okay, then 1.25. Got it B. We have 8 times 4.47. So 4.47 times 8. 7 times 8 is 56. So you write the 6, carry the 5. 8 times 4 is 32, plus the 5 that we carried is 37. Write the 7, carry the 3. 8 times 4 is 32, plus the 3 that we carried is 35. And we have 2 decimals in our problem. 1, 2. So we need 2 decimals in our answer. 1, 2. So 35.76. And then we check and make sure that's reasonable. Okay, this number would be close to 4, definitely between 4 and 5. 4 times 8 is 32. If you rounded it to 5, 5 times 8 is 40. This number is in between 32 and 40, so it is a reasonable answer. And C, we have 2.63 times 9. 9 times 3 is 27. Write the 7, carry the 2. 9 times 6 is 54, plus the 2 we carried is 56. Write the 6, carry the 5. 9 times 2 is 18, plus 5 is 23. We had 2 decimals in our problem, so we need 2 decimals in our answer. 23.67. 23.67. Okay, so next we're looking at annexing zeros in the product. If there are not enough decimal places, in the product, you need to annex zeros to the left. To annex a 0 means to place a 0 at the beginning or end of a decimal. So for number 4, we have 2 times 0.018. So we'll do this work right over here. Remember, we like to write the longer decimal place in the first row. So 0.018 times 2. Okay, so the longest number goes in the top row. 2 times 8 is 16. Write the 6, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 0 is 0. 2 times 0 is 0. Okay, so we're copying those zeros down, or you can add them in at the end. Our problem had 1, 2, 3 decimals, so our answer needs to have 1, 2, 3 decimals. So our answer is 0.036. Okay, example 5, we have 0.012 times 4. So 0.012 times 4. Okay, 4 times 2 is 8. 4 times 1 is 4. Okay, you can stop there if you want to. And again, your 5th grade teacher may have had you stop there or going on. But let's say you stopped there. in our problem, we had 1, 2, 3 decimals. So in our answer, we need to have 1, 2, 3 decimals. And then what goes in that empty space, we're going to annex a 0 there. So there's nothing here. We can't just move our decimal over. We need that 0 as a placeholder because this is 48 thousandths, not 48 hundredths. And then in math, we don't just write 0.048. Okay, we always want to have the 0 before there, so before the decimal, so that it's obvious that it's a decimal. So it really stands out, because sometimes depending on how big you write your decimal, it may be overlooked. So we always do 0.0. Okay. Then we check by adding. So this was 18 thousandths 2 times. So 8 plus 8 is 16. 1 plus 1 is 2. 0 plus 0 is 0. We lined up our decimals, and 0 plus 0 is 0. So 0.048. Oh, I just did the wrong one. That was number, I didn't carry my 1 there. That's a 3. Okay, so here's the one we want to check with adding. This one was 0.012 4 times. Let's get the camera here. So 0.012 4 times. We did the multiplication. We said it was 0.048. And we can check that with repeated addition. 2, 4, 6, 8. 1, 2, 3, 4. Zeros, line up the decimal, and 0. 0.048. Okay, and then we have got it A. We have 0.02 times 3, or got it D, excuse me, 3 times 0.02. So I'm going to put the longer number in my top row. So this will be 0.02 times 3. 3 times 2 is 6. 3 times 0 is 0. 3 times 0 is 0. We have 1, 2 decimals in our problem, so we need 1, 2 decimals in our answer. So our answer is 0.06. And then on got it E, we want to write that longer number in the first row. So it's 0.12 times 8. 8 times 2 is 16. Write the 6, carry the 1. 8 times 1 is 8, plus the 1 we carried is 9. 8 times 0 is 0. We had 1, 2 decimals in our problem, so we need 1, 2 decimals in our answer. So our answer is 0.96. And if you think of this like money, this should help you to make sense of it. So this would be like having 2 cents 3 times. 3 times 2 cents would be 6 cents. Okay, this would be like having 12 cents 8 times. Okay, so 8 times 10 cents would be 80 cents. 8 times 2 cents would be 16 cents, so 96 cents. All right, so that should be helpful if you think of it like money. All right, if you think of this one like money, 0.04 would be 4 cents. 0.045 would be 4.5 cents. So about 5 cents. If you had 5 cents 11 times, you would have 55 cents. So this answer is going to be a little bit less than 55 hundredths, or a little less than 55 cents if you think of it like money. So let's go ahead and do number 11. We have 0.045 times 11. Now this one we have 2 rows of multiplication. So we're going to have 2 things here. We'll add them up and then we'll get our answer here. Okay, so we have 2 rows of multiplication. 1 times 5 is 5. 1 times 4 is 4. I don't need to do the zeros. You can if you like to, though. It's fine if you prefer to. Now we're moving over here to the tens place, and we'll put our answer. So this is the one we're working with next. And we're going to start our answers by lining it up over here. It's not actually a 1. It's a tens place. A 1 in the tens place. So 1 times 5 is 5. 1 times 4 is 4. And I don't need to add those zeros. I can put those in at the end. So then 5 plus nothing is 5. 4 plus 5 is 9. Nothing plus 4 is nothing. Now I have 1, 2, 3 decimals in my problem. So I need 1, 2, 3 decimals in my answer. So this is 0.495. Okay, and remember we said that's about 5 cents. It's actually less than 5 cents, but approximately. So if you had 5 cents 11 times, that would have been 55 cents. This is pretty close to 55 cents. It's 49.5 cents. Okay, so next, let's go ahead and turn the page to 196. And let's look at the guided practice. Actually, let's look at the recipe problem. A batch of trail mix calls for 1.2 pounds of dry cereal. Nigella is making 5 batches of trail mix. So she already has 2.5 pounds of cereal. How many more pounds of dry cereal does she need? So each batch is 1.2 pounds. And she's going to make 5 batches. So first we multiply 1.2 times 5 and we get 6. But she already has 2.2 pounds. So how much more does she need to make? So we have the 6 pounds that she needs total minus the 2.2 that she already has, means she needs to make 3.8 pounds more. Okay, so she won't need to, that would be times 4 here. She would need to make 4. 3 batches wouldn't be quite enough. So she would need to make 4 batches. So she actually doesn't need to make the 5th batch. Next. Sorry. We have 2.6 or 2.7 times 6. So we're going to go ahead and write our problem. 2.7, the longer number in the top row, means we have fewer rows of multiplication, times 6. 6 times 7 is 42. Write the 2, carry the 4. 6 times 2 is 12, plus the 4 that we carried is 16. 1 decimal in our problem means 1 decimal in our answer, so our answer is 16.2. Box your answer. If you want to write it on the line, you can, but this is fine here. 0.52, as long as your answer is boxed, it's fine. 0.52 times 3. 3 times 2 is 6. 3 times 5 is 15. Write the 5, carry the 1. 3 times 0 is 0, plus the 1 that we carried is 1. So we have 1.56. We had 2 decimals in our problem, so we need 2 decimals in our answer. So our answer is 1.56. Number 3, we have 5 times 0.09. I like to write the longer number in the first row. So 0.09 times 5. 5 times 9 is 45. Write the 5, carry the 4. 5 times 0 is 0, plus the 4 that we carried is 4. So 45. We have 2 decimals in our problem, so we need 2 decimals in our answer. And we always write that 0 to the left of the decimal, so our answer is 0.45. Number 4, we have 0.027 times 4. 4 times 7 is 28. Write the 8, carry the 2. 4 times 2 is 8, plus the 2 we carried is 10. Write the 0, carry the 1. 4 times 0 is 0, plus the 1 that we carried is 1. We have 3 decimals in our problem, so we need 3 decimals in our answer. 0.108. Number 5, 0.071, so 71 thousandths times 8. 8 times 1 is 8. 8 times 7 is 56. Write the 6, carry the 5. 8 times 0 is 0, plus the 5 that we carried is 5. We have 3 decimals in our problem, so we need 3 decimals in our answer, so it's 0.568. Number 6, 0.065 times 18. So now we have two digits in our second row. So remember, we're going to have 2 rows here. We'll add those together to get our answer. 8 times 5 is 40. So we write the 0, carry the 4. 8 times 6 is 48, plus the 4 that we carried is 52. You can write the 2, carry the 5, or if you see these are all zeros, you can just write the 52 here. Okay, that 5 looks a little like a 6. I'm just going to make that a little neater. Okay, 1 times 5 is 5. 1 times 6 is 6, and you can or not write those zeros to the left. It's up to you. Then we add these two rows together. We get 0, 7, 11. We had 1, 2, 3 decimals in our problem, so we need 1, 2, 3 decimals in our answer. So our answer is 1.17. We don't really need that 0 there, 1.17. We'll put it here, but we counted from the, I'm going to leave it there because we actually counted from the right. 7 is a two-step problem. We have a bee hummingbird. So I'm assuming that's some sort of hummingbird. A bee hummingbird has a mass of 1.8 grams. How many grams are 6 hummingbirds and a 4-gram nest? Okay, so how much does 6 hummingbirds and a 4-gram nest weigh? So we have each hummingbird is 1.8 grams, so we do 1.8 times 6. Okay, 6 times 8 is 48. Write the 8, carry the 4. 6 times 1 is 6, plus the 4 that we carried is 10. So we have 1 decimal in the problem, 1 decimal in the answer. So that's how much the hummingbirds weighed, plus we need that 4-gram nest. So 10.8 grams plus the 4 grams for the nest will be 14.8 grams. Justin buys 12 pencils for 56 cents each. He pays with a $10 bill. How much change will he receive? So the pencils are 56 cents times 12 pencils. So 0.56 times 12. I'm going to work, I don't really have enough space here, so I think I'm going to go up here. $0.56 per pencil times 12 pencils. 2 times 6 is 12. Write the 2, carry the 1. 2 times 5 is 10, plus the 1 we carried is 11. 1 times 6 is 6. 1 times 5 is 5. So we have 2, 7, and 6. We had 1, 2 decimals in our problem, so we need 1, 2 decimals in our answer. So the total was $6.72. However, the question was, what's the change? So how much change will he receive from $10? I like to count up from the change. So if this is $6.72, okay, so that would be, if I were paying with $10, how many dollar bills would I get back? Okay, well, if you rounded that up to 7, you'd be getting $3 bills back, okay? And then you at the round count up to the 90 or to the 100 cents from the 72. 82, 92, that's 20 cents. And then from 92 up to 100 is 8 cents, so 28 cents. So I like to count up with the change. I used to work in a store, and that's how we had to count back the change. Okay, or, so this is our answer, or you can do the standard algorithm. You can do the $10 minus $6.72, and you can borrow and regroup and subtract. Okay, so we need to borrow, borrow, borrow. We come over here. This becomes a 10 and a 9, and a 9 and a 10. 10 minus 2 is 8. 9 minus 7 is 2. Line up the decimals. 9 minus 6 is 3. So you can also do it with the standard algorithm for subtraction instead of counting up. And then our last question, how can estimating products help you to place the decimal correctly? You will know if your answer is reasonable. You will know your decimal is in the right place if your answer is reasonable. You will know your decimal is in the right place when your answer is close to your estimate. Let's say that way. When your answer is close to your estimate. Okay, so here, And we're not talking about close, like within a digit or so. We're talking about in the same place value. So like, 50 cents or 56 cents versus $5 or $50 or 500. So if you look at this example number 5, if you think of this like money, this would be about 7 cents 8 times. Well, 7 cents 8 times would be 56 cents. Okay, so this is pretty close to 56 cents. Now, if it were 5.68, so $5.68 or $56.80, or if I just had $568, okay, or 568, I would know I'm off. So that estimate just helps us to know if we have our decimal in the correct place. Okay, and that is computing with multi-digit numbers, lesson 3.3, multiplying decimals times whole numbers.